Hello, welcome to Devlog 2. Today we're going to be talking a little bit about, well, a lot about what has changed. And the answer is a lot has changed. In the last devlog we talked about the Sourcealyzer. The Sourcealyzer is a program that was designed to convert data, or sorry, you had both the source map from Black Mesa's original VR mod and the map from the actual Black Mesa, and it would kind of create somewhere in between. But after playing the next few maps, that is not sustainable. And so what I've started developing is a tool that completely takes the original maps out of the equation, other than for reference by me. This is the BMSS translator, as I've called it here. Its modern name is the BMST, the Black Mesa Source Transpiler. And what it's designed to do is to take a Black Mesa map, the decompiled data from a Black Mesa map, and convert it into a source map with as little quality loss as I possibly can. Right now, it is obviously not finished. There is quite a few things about it that are pretty nicely working. So it is again programmed in Lua because Lua is just a great programming language. Here's the GitHub. If you want to look at it, it's in the description, the GitHub. And you can see here, if we go to the actual code, it actually does have quite a lot more than, like, of code than the other one. So quickly, I'm going to go over the code. You can see here, it is powered by LuaJIT, and for that reason, I included LuaJIT as a dependency in the third party. This is not what's it, like a secondary package or a subdirectory. It's just copied and pasted. I just copied and pasted it because I pre-compiled it on my computer. If we go here, you can see that because of the much higher scope of this project compared to the Sourcealyzer, there is a lot more code. We have main.lua, and what this does is, I know I didn't really go over the code last time, but and of course, you see, I don't know, I would like to, oh yes, I would like to open the repository, please. Thank you, please, if you could, or don't. Or, no, that's fine. I didn't want you to, like, when you asked me to do it, and I said yes, I didn't want you to do it anyway. Okay. Now, if you look here, you can see what this basically does is, if you've never used Lua before, it's kind of disorganized, but this is basically just the orchestrator of everything. So this basically just gets a bunch of data, and if you think about it, there's a few steps needed to take the map and transpile it. The first one is parsing. The data from the raw txt file, or VMF file, the raw data needs to be converted into a table to work with. The previous Sourcealyzer did not do this. It simply did string manipulation. Because of the higher scope of this project, it was undescribably necessary to do this. So the first thing that we do is we open the file that the player gives us, or the user gives us, and we use a module created called VMF parser. And what VMF parser does is it does exactly what it says. If you look over here, I'm not going to go too into detail of how this works, because it's kind of complicated, but it takes advantage of the fact curly braces like these and a few other things to do a lot of stuff, a lot of logic that I don't even really remember, that basically converts the file into a table. That's all you need to worry about. And it returns the VMF table along with some other telemetry stuff. And at the end of the process, that needs to be converted back into a string. So table the string does that. It basically takes it and converts it into a string. But in the middle, that's where all the magic happens. And so that's where the transpiler module is used. And the transpiler module, I'm not going to lie, it isn't the most organized. I do need to reorganize it a bit. It's all right. But basically how it works is this. When you fire the transpiler, you give it the table of all that stuff. And it's cross-referencing with another file that it has. If I open that. In the resources lists folder called source class names. This is every single class in the source engine. I'm probably missing a few, and I'll add those as I go. But this is, for the most part, every single class in the source engine. not every class in the Zen engine. And what the transpiler has a few duties it does. And while this one should be abstracted, or not abstracted, but moved to a separate function to stay organized, it goes through the VMF table on separate passes. So for one pass, it'll do something, modify the VMF table, then go to the next one with the new data. Right now, it's only doing 2 passes. So if we look here, you can see the first pass, what it does is, by the way, block calling get attributes. A lot of the time spent today was mainly just object orientifying everything because it was kind of disorganized. You can see here, there's block classes, there's connector classes, and attribute classes. I'll talk about the connector class in a bit. Attributes and connect the blocks. A block is like a section of a VMF file, and an attribute is like a specific, like it'll say, you know, target name is like, I don't know, cc_183 for the target name of the file, or the entity. An attribute would be that name, and a block would be the entire block of data. And basically it's checking, are you actually in the source name? Does your class exist within source? And if it doesn't, then it's not passing. For this, it returns nil if it cannot pass, or it returns the block if it does want to pass. So kind of similar to like string stream from C++. It's like a super weird thing to fall back. It is kind of true. If target name, basically, else if it does pass, then we add it to a list called all target names. And the reason why we do this is because the next pass needs that data. The object, basically, it goes through every single object in the VMF table and gets its connections block. If it has a connections block, which not all objects do, it'll fire connections.transpile on it. What does transpile do? Well, or what's transpile do? What does connections.transpile do? What is connections? Well, connections handles the connections. Each block, like logic blocks, have connections to other blocks to form logic chains. And those, if are even slightly incorrect, will cause it to crash. I believe as it currently stands, it still does crash. I haven't tried opening it with normal Hammer. Hammer++ just circumvents that crashing problem entirely. So I would recommend you use that. But basically, what this does is it goes through every single one, and it parses it based off of a separator, creates a connector class out of that data, or I guess it'd be preferred to call it like a structure because it doesn't have any methods, or namespace, or even an enum. I guess you could call it an enum. No, not really. No, it's not an enum. No, it would be like a struct, yeah. And it goes through and it turns it into a table. It parses it into a table. With deep parses at the end, of course. And it's basically, right now, is connector stable? This function is sort of basic right now. This basically, if it returns true, the connector passes. If it returns false, it does not. And basically, it's checking, is there a target for it? It's checking the target names. Is there a corresponding target for it? Basically, if the logic block or whatever is pointing at nothing, well, then we can't add it. And why would it be pointing at nothing? It would be pointing at nothing if what it was pointing at got removed in the previous pass of the transpiler. So these things kind of get complicated. The more things that we want to do to change it, the more things that depend on other things. So, you know, connections depend on the target names, and the target names depend on what names the source engine has. Additionally, when it comes to refabbing, which I'll get to in a second, some connections need to change their names entirely. So what is refabbing? What is refabrication? That's not currently something implemented, but that is the next step. And by the way, if you're wondering, the other things I didn't mention, STD, these are just a bunch of standard things that I added. For example, like a string library that just adds a white space, a standard library that just references other things, table, a better counter. It's just some basic stuff because Lua is it's a pretty bare bones language. I like that about it, but that is, you know. What is a refab? Well, if we go to the GitHub repository and we click refabs, I think it pretty much explains it well. Refabs are designed to be a multi-class replacement for single-class Zen engine components which don't have a direct substitute in source. If you don't know what that means, think of it like this. In the Zen engine, the Black Mesa version, let's say there's a trip mine, an explosive trip mine. I'm not sure if it's one class, to be fair. As far as I know, I think the red trip mines are not one class, but the blue ones are. Could be wrong there. Basically, there's no, like, that's a modified version of the source engine, right? So we don't have that. That's Zen engine is modified to the source engine. You modified that class in. We don't have that class. So our only option is to try to recreate it. For example, the explosive trip mine that's seen We've Got Hostiles, which is actually why I chose the first map to be the first map that We've Got Hostiles, because there's a lot of things we need to add there, like the turrets and the trip mine. Basically, there's no replacement. What do? Well, we create a replica. Basically, for that, we could probably use like a trigger, a model, and like an explosion, or and a logic to handle the flashing, and a sound entity to handle the sound. Okay, cool. We have that. How do we actually slot that in? And that's where this comes in. A refab is a multi-class replacement, so a trigger, a physics object, a sound, a logic, all tied into one package called a refab. And what happens is that refab will specify what it needs to replace. For example, I'm not sure what it's called. It's probably like explosive trip mine. If there's explosive trip mine, there's a metadata file inside of the refab that will point to explosive trip mine and say, hey, Transpiler, if you find explosive trip mine, replace it with all these stuff in this order relative to it, please. And so what happens is it'll have a VMF file. It'll parse the VMF file. It will have another metadata file, which is very similar to a VMF file, but it's not a VMF file. It's the same format because I don't have to make another parser. And that will contain data like the origin is this relative to these. So you should, when you're doing your vector calculation, you need to keep that in mind when moving things. And another thing it'll have is connections. Hey, like on exploded isn't a thing anymore because the trip mine doesn't exist. Any connections that you previously had going to the explosive trip mine need to go to this explosion object or this logic object, and instead of firing on explosion, fire on done, whatever. I don't know. Okay, listen, I haven't done this yet, and that is the main job of the transpiler. Everything that transpiler has done so far could be recreated by just launching it with Hammer++. The real job of the transpiler is the refab. The refab system is the main job of the transpiler. There's two types, by the way. A direct replacement, and what I just described to you is a fab replacement. A direct replacement is like, for example, the gun. I think it's called like item underscore weapon underscore Glock or something. Of course, that's not in Half-Life 2 VR. So what we need to do is we need to replace that with, it's like weapon underscore pistol, item underscore pistol. Oh, I don't know what, I don't know exactly what Half-Life 2 calls it. That's pretty simple. It just contains a metadata file saying, if you find this, replace it with this. It's that simple. This is going to take the longest, but it's going to be the most important part. Right now, if I were to go in game, it's just completely bland. The door's open. There's no NPCs. NPCs are also, I think NPCs might be directly usable with like the NPC citizen class and a lot of modification, but it might have to be fabbed. That's the current plan for the BMS transpiler. Right now, pretty much most of the stuff works, but let me actually show you where we're at. So if I run the run.bat file, it says path to Black Mesa map. So right now I have it in testing, and again, like I said, this is the first map of We've Got Hostiles. So I'm just going to do /testing/that.vmf, press enter, and it does all that. You can see it parses it. It took 0.34 seconds to turn that gigantic 1200 kilobyte file into a table. That is crazy. 592,000 lines in 0.34 seconds. I love Lewis so much. Transpiling, and it took a very short amount of time. 24 types were found that could not be translated. And these were the types that it could not translate. New light spot, that's something from Black Mesa. NPC Central Ground, that's from Black Mesa. All these item weapon Glock, that's from Black Mesa. These things couldn't have a direct replacement. It writes it. And now if we open the file in Hammer++, which has better error checking, which is why it works. You can see here we are. We're in the map now. And while a lot of things are kind of weird and kind of not working, like, what are you? And, oh, sounds good. Where are we? Oh, this is the start. Okay, I'm just going insane, guys. Don't worry about it. You can see, what are you? Item, weapon, shotgun. Interesting. I opened the wrong one. I opened the testing. See, this is I'm stupid, okay? I opened the wrong one. It's output. I have to open I just opened I need to open the file out after it's done transpiling. This is the transpiled file. I just opened the original Black Mesa map for some reason, like a dumbass. And that proves my point, by the way. Hammer++ can just open Black Mesa maps. If you go to this logic relay, usually it has a bunch of missing connections, but now if I look at it, you can see it only has a few, and they're all valid, because if it can't find the target name, it automatically removes the connection. That alone should allow it to be open in Hammer. I don't know. I haven't tested it. You see all the, like, I forget what it's called. I don't know. It's not there anymore. That's my point. And you can see everything looks pretty much exactly the same as in Black Mesa. However, if I were to run this at this very moment and compile it into Black Mesa VR, which I'm not gonna do that right now, then it would run. It would run this. It wouldn't look very good. For example, this no draw wouldn't really work. There is still some human intervention required. I'm gonna have to go through and delete like a few no draws and stuff, but I'm okay with that. I'm trying to make most of it happen inside the compiler or the most of my work isn't going to be coding. Most of my work is going to be making the refabs and the metadata files for it. We missed something. Item underscore crate. Okay, we're gonna have to fix that. See, it's horrible. Okay. And yeah, this is basically just it. So this is Devlog 2 of the Black Mesa VR 2026 project is what I decided to call it. Yes, sorry if I sound like I'm rambling, because I am rambling, but I'm ending the video.